Today's lesson is about graph interpretation. I'm going to go through all the different kinds of questions that you've been asked since grade 10 to this point now in grade 11. The first question deals with working out the length of a horizontal line BC. Two things you've got to remember. If you're working out a horizontal distance, you are looking for the difference between your x values. And so the second thing is to always identify what is special about the end points of the line segment in question. So in this particular case, B and C are the x-intercepts of the parabola f of x, which is equal to minus 2x squared plus 8x plus 10. You'll notice that I did not label which graph was the parabola and which graph was the straight line, because I expect you to know that the parabola is the quadratic function, the straight line is the linear function. To work out the x-intercepts, remember we always put y is equal to 0, tidy up that equation and you land up with x squared minus 4x minus 5 is equal to 0. The factors of 5 that subtract to 4 are going to be 5 and 1. My signs are different. I want more minuses, so my brackets are x minus 5 and x plus 1. X is therefore equal to 5, or x is equal to negative 1, and the coordinates we can allocate looking at the picture. So the coordinates of point B are clearly going to be the minus 1 and 0. The coordinates of point C are going to be 5 and 0. The length, therefore, for BC is going to be 5 minus 1, which is 6 units. In the next question, we are being asked to find a vertical distance JD. When you're looking for a vertical distance, you are always looking at the difference between two y values. Ask yourself what is special about point J. It is the y-intercept of the parabola. So, to calculate the coordinates of J, we are going to work out f of 0, because to calculate a y-intercept, we always replace x with 0. So we have minus 2, and we're substituting it into the equation for f, and we land up with the coordinates of J being x is 0 and y is 10. Point D is the y-intercept of the straight line. So we're working out g of 0, and when we do that substitution, we land up with a value of minus 2. The coordinates of point D are therefore 0 and negative 2, and therefore when we work out the length of JD, we get 10 minus 2, 12 units. Right, the next question. We are working out now the length of AC. Now AC is neither vertical nor horizontal, okay? So we need the coordinates of both point A and point C, and we're going to use our distance formula from our analytical geometry section to calculate the length of that line segment. The second thing we need to take note of is what is special about point A. Point C we already know, and in fact what I should do is always write in the values that we have calculated at each point, because we never know when we are going to use them again. So A is special because it is the turning point of the parabola f of x. Remember, to work out the x value of the turning point, we always use the formula x is equal to minus b over 2a. The equation of my parabola, my b value is 8, so it becomes minus 8 over 2 times my a value, which is minus 2. Minus divided by minus gives me a positive. 8 divided by 4 gives me a value of 2. So the x-coordinate of point A is going to be 2. I now need to calculate the y value of point A, and because this point lies on my parabola, I'm simply going to substitute it into 2 into the equation of my parabola, minus 2 times 2 squared plus 8 times 2 plus 10, minus 2 times 4, 8 times 2 is 16 plus 10, and so my value here lands up as 18. I now know the coordinates of point A are 2 and 18. We have already calculated the coordinates of point C to be 5 and 0. Remember, your distance formula, AC squared, or your distance squared, is going to be the difference between your x's squared plus the difference between your y's squared. Substituting in the two ordered pairs that we have, we are going to land up with 5 minus 2 squared plus 0 minus 18 squared, and when we do that calculation we get 9 plus 324, which is 333. The length, therefore, of AC is the square root of 333, which is simplified to 3 root 37. The next question asks us to work out the coordinates of point F and point E. What is special about those 2 points? Well, they're the intersection between the line and the parabola. And when we calculate a point of intersection, we are always going to work out a simultaneous equation. We have 2 equations here. Y is equal to 6x minus 2, and y is equal to minus 2x squared plus 8x plus 10. Y equals, I land up with 6x minus 2 is equal to minus 2x squared plus 8x plus 10. This is a quadratic equation. It's got an x squared. The most important thing about a quadratic equation is everything on one side equal to 0. Tidy that up. I get 2x squared minus 8 plus 6 minus 2x minus 10 minus 2 minus 12 is equal to 0, and I need to factorize that. Easiest thing to do is to divide through by that common factor of 2, and now I'm looking for the factors of 6 that subtract to 1. That gives me a 3 and a 2. Again, my signs are different. I want more minuses, so the signs in the brackets are x minus 3, x plus 2. Gives me an x value of 3 and an x value of minus 2. Now for each one of those x values, we need to calculate the corresponding value of y. So I'm going to substitute 6 times 3 minus 2. 18 minus 2 gives me 16. The coordinates, therefore, of point E are going to be x is 3 and y is 16. For this value of x equals minus 2, I get y is equal to 6 times minus 2, minus 2, minus 12, minus 2, minus 14. And therefore the coordinates of point F are going to be minus 2 and minus 14. Again, as we calculate, put the information on your picture. So we know that that is 3 and 16. We know that F is the point minus 2 and minus 14. I forgot that I needed to fill in that value over there was 18. Right, so the next question. We're being asked now to calculate the length of FE. Again, FE is a line that is at an angle, and therefore we're going to have to use our distance formula. We already know the coordinates of both point F and point E, and so it's simply another substitution. FE squared is going to equal the distance between my x's squared plus the distance between my y's squared, knowing that point F is 316, point E is -2 minus 14. FE squared is therefore 3 minus -2 squared plus difference between my y's, 16 minus -14 squared. Okay, this lands up being 5 squared plus 30 squared, which is 925. That means that FE is the square root of 925, which simplifies to 5 root 37. So, we've revised how you calculate the x-intercepts of a parabola, how you calculate the y-intercepts, the fact that a horizontal distance is the difference between your x's, a vertical distance is the distance between your y's, and the distance of a line that's at an angle, you're going to use your distance formula, difference in x's squared plus difference in y's squared. The next question asks you to make use of the calculations you've done and interpret. So here the question says, what is, where, for which values of x, is f of x going to be greater than g of x? So looking at your picture, I'm saying, where is the graph of the parabola above the graph of that line? Okay? The parabola must be above the line. Well, that happens from this value of x, which is -2, up to this value of x, which is 3. So if we look at that section of our plane between -2 and 3, our values on the parabola are greater than the values on the line. And so our answer becomes x is an element of the interval from -2 up to 3. Notice I said greater than, not greater than or equal to, and so I'm not going to include either of those two endpoints. The next question is different. I'm asking you where the product of the two graphs is positive. Now you need to understand that if a product is positive, it either means that f of x is greater than 0 and g of x is greater than 0, or f of x and g of x are both going to be less than 0. A plus times a plus is a plus, a minus times a minus is also a plus. So I'm really looking for the intervals where the signs of these two functions are the same. Now if you have a look on the picture, as I move from -infinity all the way up to that x value of -1, both my graphs f and g are negative. A minus times a minus would give me a plus. So the first part of my answer is going to be anything from -infinity up to that value of -1. Again, there's no equals, so I am excluding my endpoint. Now, here in this interval, from -1 up until this point over here, my parabola is positive, my line is negative. Okay, so I need to know what is this point over here, because from this value over here, which I have not labeled, and I'm going to call it M, from this point over here, my line and my parabola are both positive until I reach this value of 5 over here. So what am I going to do? I need to work out the coordinates of that point M. Ask yourself the question, what is special about this point M? Okay, it's not just any old random point on my picture. At M, okay, I'm looking at the x-intercept of my straight line. In other words, y is 0, and I can calculate my value of x. 6x will equal 2, and so at that value of M, my x value is 1/3. This value over here is 1/3. So from 1/3 up to this value of 5 over here, both my parabola and my line have positive y values. So my answer is that interval, or the interval that goes from 1/3 up to 5. The last question, H, is asking you to find the maximum possible length of GH. GH is a vertical line, so we have already established that when we are calculating the length of any vertical line, we take the top y value, which in this case is f of x, minus the bottom y value, which will be g of x. Notice that for different values of x, that vertical line changes in length. Over here it's very small. As I move across, my x values, different x values, are generating longer and longer and longer values of the length for GH, the distance between the parabola and the line. At some point, those lengths start getting smaller and smaller again, and so somewhere over here, we must find a value of x which generates the maximum possible length of GH. Alright, so we established GH is a vertical line. It is the y value of the parabola minus the y value of the line. Well, the equation of the parabola was minus 2x squared plus 8x plus 10. We are subtracting the equation of the line, 6x minus 2. I need to tidy that equation up, and I get minus 2x squared plus 8x plus 10 minus 6x plus 2. The length of GH varies according to this particular quadratic. That quadratic, if we haven't drawn it, but if you did, it would be a parabola that looks like that. Where is the maximum of this particular quadratic function? At its turning point. How do we work out that turning point? We use the formula that says x is equal to minus b over 2a. Minus 2 over 2 times minus 2. Minus divided by minus is a plus, and my answer would be 1/2. This means that at an x value of 1/2, I will be able to work out a value for GH, and that value that I calculate will be the maximum possible length that GH can have. So we do the substitution, minus 2 times 1/2 squared plus 2 times 1/2 plus 12. And when we do that calculation, we land up with a value of 12.5. That tells me that the biggest distance between the parabola and the line is going to be 12.5. That is going to occur when an x value is 1/2. Right, now what I want you to do, please, is to this is now the end of the first video. I want you now, please, to do the examples that I have just gone through with you on the worksheet yourselves, so that you can check that you've really understood. Please go through the video again once you have completed the examples to make sure that you mark them and that they are 100% correct. Thereafter, I want you please to do question 2, which is exactly the same kinds of questions as I have done with you, but using a different diagram. Thank you.